It's my pleasure to be here today and introduce an incredibly talented, amazing panel of individuals who are every day going out into the world and really trying to do disruptive and transformational technology implementations into the world. And this stuff is hard. I have the easy job of sitting on the sidelines and supporting them, but they are doing the challenging day-to-day struggles of building a clean tech startup. And so today, the theme of today is really to talk to them about their experiences as founders, what inspired them, what they're doing, and the journey that they've been on over the last year or several years, lifetime, frankly, to bring some of these technologies into the world. And so we're going to sort of walk through the journey for the first sort of bit of session here, and then we will open it up to the audience for questions as we approach the end. But as a starting point, I'll just let each of the panelists introduce themselves, just to kind of give you a flavor of who all is here. So starting with Natasha.
Oh, hello. So I'm Natasha Kostanuk. I'm the CEO and co-founder of Ayrton Energy. We're based here in Calgary. And Ayrton is developing hydrogen storage technology. So basically, most people are very focused on hydrogen production or hydrogen end use, but the bottleneck to broad hydrogen adoption is the storage and transportation. And it's very hard because it requires very high pressures or liquefaction, low pressures or low temperatures, and this requires complex logistics, brand new infrastructure. And what we're doing is called a liquid organic hydrogen carrier, or LOHC, which basically takes hydrogen gas and chemically binds it to a carrier oil so that it's a room temperature, room pressure liquid that can go anywhere liquid fuels go. So anywhere you can put diesel, we can put hydrogen. Tanks, trucks, pipelines, rail cars, ships, no modifications needed. It has the same SDS properties as diesel. And the advantages of that is obviously quicker adoption of hydrogen and without having to rebuild all of the infrastructure. I think that everybody thinks that, we'll do energy transition or energy we like to call addition. I don't think we need to really necessarily change what we're doing. We also need to keep adding more energy to our energy sources. And there's a bottleneck and a real slow to adopt when you have to start by rebuilding every tank, truck, pipeline infrastructure that you need. And so being able to reuse what the world already has is kind of our key topic and focus at Ayrton.
Awesome. Mina.
Okay. Hello, everyone. I'm Mina Zarabian. I'm CEO and co-founder of Carbonova, also from Calgary. We convert carbon dioxide and methane, both greenhouse gases, into advanced carbon nanofibers that is an additive for plastic and for batteries. Similar to the story that Tasha was saying, that there are a lot of focus in CO2 capturing and storage, but at the same time, that's liability, and with the shift in economic, that's becoming more challenging to be implementing. We had that focus from the beginning: how can we generate money and generate value from CO2, from greenhouse gases? So we built this technology. It's a catalytic chemical process that chemically convert carbon dioxide and methane into advanced carbon nanofibers and the byproduct of water. The process is designed to be an exothermic process. So as it happens, it generates energy and reduces the total energy demand of the process. Where does the carbon nanofibers go? We're mainly now working with composite and plastic industries. We're working with automotive, enabling them to use more reinforced plastics for lightweighting as well as sustainable materials. So they have goals around using more recycled plastics and lightweighting to get to energy efficiencies, and that's where we come and help them.
Awesome. And Curtis, in full disclosure, Evok led the Series A round into Rototherm this last year, so very proud to have Curtis leading the latest investment in our fund. But over to you, Curtis.
Hi there. My name's Curtis Cook, and I'm the founder of Rototherm Energy. We're actually centered here in Calgary, but we are also in Salt Lake. We are a geothermal developer. As Erin mentioned, we just, about 75 days ago, closed our Series A. We just raised $38 million, Evok led, and I'm very happy that Evok has leaned in and participated and partnered with us. Our background as a team is from oil and gas, a very, very long pedigree in that industry, having founded a few companies. Lastly, unfortunately, not to put the Darth Vader hat on, a shale oil company, which we grew successfully to a very large company. But what we started looking at geothermal as a resource in 2020, and we quickly realized that it was unable to scale because of its poor economics. And through many iterations, we came up with a design that is essentially a heat pump at depth. So working with our partners, Halliburton and Baker Hughes, longstanding partners, we've created a system that is essentially a heat recovery system or a heat pump, or to be silly, the back of your fridge, and bringing it downhole to industrial scale power output. And that solves for consistent cash flow, low operating expenses, and that is critical to scale any project in the energy space because you need a lower cost of capital.
Awesome. So you have a flavor of what we're getting into this afternoon. So I want to talk a little bit about digging into kind of your origin stories. Like, what inspired you to take on this journey? Tell us a little bit about what inspired you and how you got to this point in time, and where are you now in your journey in terms of some of the key milestones, deployments, sort of where are things at? Mina, go ahead.
Let's mix it up a little.
Yeah, okay. Go ahead.
All right. So I was working on my PhD back in 2015, so almost 10 years ago. And I was seeing a lot of my colleagues in oil and gas, or our whole group was having challenges because of CO2. So that was starting to be initiating how can we use that same knowledge, that same expertise that exists in our chemical industries to use for something different and tackle the CO2 problem. And that whole CO2 problem from the beginning was nobody wanted to touch because it was cost and was not generating value. And my background was material science engineering, so I wanted to connect these two dots and convert carbon dioxide to advanced materials that can go to lithium battery application and composite. So that was the initial inspiration. What was the second part of the question?
Where are you at? Like, what's the journey been like? What are the kind of milestones that you've unearthed, and where are you now?
So at the university level, we had a proof of concept in the lab, so that the challenge was scale that up and raise money and continue developing technologies and work with customers to offtake the product. So there were 3 areas of challenges ahead of us: market, financing, and then continue technology development. So we raised money, we built a pilot unit that is up and running. We have so far raised over $25 million, a combination of non-dilutive and equity. And we are now heading to build our first commercial demonstration unit. We had a very recent raise that is not yet announced. It will be announced next week. But that will be toward building our first commercial demonstration unit here in Calgary. And we will be utilizing carbon dioxide directly from one of the facilities here in Alberta and convert that into carbon nanofibers that will be exported partially to Europe, US, and Asia.
Yeah, congrats. My background is similar to Curtis. I'm a mechanical engineer by training, and I spent 19 years working in oil and gas in an energy service company. Very lucky to have a good career that spanned a lot of different roles, and so from technical to operations to sales, kind of ended my time there doing business development, where I was taking chemistry, like downhole frac chemistry, for example, and licensing it to mining companies in Wisconsin. So it helped me really kind of see how you can take existing technologies and apply them in different ways. I then left oil and gas for a little while and worked with a various amount of startups, anywhere from software, some hardware, lithium extraction technology type startups, before meeting my co-founder. And I actually hired her. She's a PhD chemist, did her PhD in fuel cells. and I hired her to help me build a hydrogen generator type company. I wanted to use hydrogen to kind of fill the gap on some of the energy needs that we need. And she kept bringing me hydrogen storage solutions that I thought were silly. I was like, this doesn't work. Like, it must be a better way. Somebody's already solved this. Like, let's just talk to them. And if it was a movie, it would show us, in 5 minutes at the kitchen table with the idea. And it's not a movie. So it took maybe, 6 or 8 months to kind of come up with our path forward and thinking about that. And once we realized that we've kind of solved hydrogen storage, we decided to not build hydrogen generators, instead focus on solving hydrogen storage. So that's kind of our origin story. And we've been around for almost 4 years. We have a team of about 20 people. We have scaled our systems up from, so I should back up a little bit and say that our technology is using existing to follow the same trend. LOHC has been around for decades, using high temperature, high pressure, chemical plant type processing. It's actually how you make margarine. If you take canola oil and you add hydrogen at high pressure and temperature, it makes margarine. So we're doing something similar, but we took that process and adapted it to work electrically. So we electrified it, and our system now looks like electrolyzers. So it's very modular, very scalable. Instead of being at 500 degrees Celsius, we're less than 100 degrees Celsius, so it's more economic, et cetera. And so we've scaled our technology from very small, lab bench type systems. We did our first deployment last year with ATCO Gas, just a little baby unit at their hydrogen demonstration facility in Fort Saskatchewan. And now we're in the midst of building up a 30 kilogram per day system that's going to be deployed in Hawaii. And super excited to be working there. And we're already in discussions for a ton per day, a demonstration system with multiple partners, two in North America, one in Europe, and a couple in Asia. And so that's kind of our journey. And I guess you asked about fundraising. We raised $1 million in 2023, led by a New York investor. And last year we raised $6.8 million, led by BDC Capital and Clean Energy Ventures, and a couple of Singapore-based investors. And then we plan to launch our Series A sometime next year after we deploy the pilot.
Amazing. And we were joking earlier that Natasha's not sure exactly what time zone she is. I think that's consistent across all of our panelists who are literally going around the world to talk to various investors, partners, customers, et cetera. But Curtis, please lend us your story. Where did this all come from?
Apart from, again, we are a group of engineers, as that's how we started. We started looking at conventional geothermal. We started looking in California. And ultimately, we couldn't understand why, again, they weren't having consistent cash flow. We couldn't understand, essentially, as a product, how to scale this. So we quickly started throwing a whole bunch of ideas at the board, and we came up with relying upon known heat recovery systems, which are essentially a real-world Carnot cycle. So what that practically means is you go down, you have a fluid, you go down with a liquid, and it turns into a gas, and that gas comes shooting out of the ground and then into a turbo expander and generates electricity. That is exactly how you do geothermal in Iceland, and that's why it's so prolific there. Unfortunately, we don't have the heat in all the other areas, so you need to adapt, and we've been doing that as an industry for 150 years with different refrigerants, and that's the big word. But practically, all we did is we said, okay, well, why haven't someone used the technology from horizontal drilling? Again, we're mostly reservoir engineers and mechanical engineers. Why haven't they put together a system whereby we can generate heat and convert it into electricity at a reasonable cost? So our first project, so as part of our raise, our first commercial demonstration is in Utah, and it falls under as part of a much larger 100 megawatt project. Where we have offtake into the state of Utah, and we're working on several other comparable projects of that size. Internationally, some of our investors are also TDK Ventures and Toyota Ventures and Tech Energy Ventures, who are interested to assist us in bringing this to other jurisdictions. So Natasha's a little bit farther ahead than I am. I've only had this for 75 days. So essentially I can only move so fast. But ultimately, the uniqueness of what we are doing is financially underpinning the results, but also we do not use water. And that is a critical component. We don't use any water. So we don't use any surface water, we don't use any groundwater, we don't do any mass transfer downhole. So we do not have any issues of seismicity and you know, again, I don't want to dive into the geothermal space, but inevitably we start talking about EGS and AGS and all these different things. Our view is great, but it's still inefficient because you're using water. And everywhere on the planet, with exceptions of very small areas, have a problem with fresh water. And again, as a poor refrigerant, we quickly honed in on organic refrigerants because of their versatility. Everybody knows how to operate them, and they're very, very low cost. So that's what we did.
So, Curtis, staying on that thread, if Rototherm is wildly successful beyond your dreams, what does this look like? Where does this scale to? What does this kind of look like, you know, at full tilt? And what are some of the challenges in terms of the barriers and the obstacles, technically, regulatorily, financially, that stand between, you know, where you are now and that potential outcome?
Sure. So I'll use Salt Lake as an example. If we're wildly successful, when you fly in, you'll see us right beside the city. Literally all across, and it's a very, very small surface footprint. You probably won't even notice it, but it's only 800 feet by 800 feet, the whole thing. And that's input, output, 5 loops, a turbo expander. We only have one moving part, so you put a house over it, you won't even notice it, if you want to do that. But that's the wildly successful, because we don't do what some of the other technologies do. We're able to be placed in sensitive areas, close proximity to cities. Some of the challenges, honestly, are just relaying this story. Because inevitably it took me, I don't know, probably I'm not very good at it, but it took me maybe 5 sentences to do that, whereas everybody else is, you know, 24/7. You know, you're like, well, that's great. But I need to convince mostly people to understand that you're already running this system in your fridge, in your home right now, which is running in isobutane. That's what you're actually running. You're running the exact same system that we're running industrially. But inevitably, when we start talking about it, people kind of go, well, you know, has this been done? So we're solving for that first of a kind and having our first commercial demonstration. We're starting, actually, we've already started, but practically we start in January, and we'll be on production by September, generating electrons. And then we will no longer have the discussion of first of a kind.
Awesome. Mina, do you want to? What if you're wildly successful, and what gets in the way?
So we are also in the process of building our first commercial demonstration unit. That's a unit that is both commercial, similar to what Curtis is explaining. You have some offtake potential that's going to generate the first type of revenue, consistent revenue for the company, but it's also still demonstration. You're going to show the world that what is the potential for this technology. So you got to do both, and that's one of the challenge with this stage of the business, because you're building almost 2 types of companies. One is focusing in the business development, in showing the world the potential of where this goes, and the other one is to be like a operational companies and generating revenue, working with customers and servicing the company. So widely successful is achieving both those 2 goals with the first commercial demonstration unit that we're building. Our business model is both licensing the technology, and we have potential licensors that want to build very similar of this unit in other locations. And we also, the other part of our business model is build and operate, and being able to build a gigafactory. That's the dream in Canada, in Alberta. And the product that we are making is is very lightweight, is very valuable product. It can be just transferred with the existing infrastructure, even if it's been transported by plane. From the economic perspective, it makes sense because it's very light. It doesn't need pipeline to be built, and that's the goal, to focus the build in Canada as much as possible.
Yeah, so our first pilot in Hawaii is not our commercial scale. It's only in kilogram per day range. And if you're in hydrogen, nobody cares about kilograms per day. Everybody wants tons per day. We have customers we're talking to that want 100 or 200 or 300 tons per day. And so it's been, for us, one of our challenges is getting attention and making progress in the BD world when, they're talking about a couple hundred tons per day and they're like, what have you done to date? And you're like, well, here's a system that does grams per day in the lab. And so that's been one of our challenges. And so as we continue to scale up and deploy scaled up systems, that kind of helps. For us to be wildly successful, it's doing that hundreds of tons per day capacity, and our system's easily scalable to that size, just like electrolyzers are. And wildly successful for us is helping people make hydrogen where it makes sense. It should be made in low-cost areas using whatever feedstock that you have for where you are. We're just very practical that way. We don't believe in colors of hydrogen, and we don't think there's one that's better than the other. If you're in Alberta and the cheapest feedstock is natural gas, you should use natural gas. If you're in, a really sunny place like Australia, you should use, solar there to make hydrogen. So really it's about taking low-cost hydrogen and bringing it to where people need it. We're not running this building's heat, their natural gas from a well in the parking lot. We make the gas where it's low, where it's made and where it's low cost, and we bring it to where we need it, and we want to do the same for hydrogen. And so I would say our biggest challenge from here to wildly successful is doing everything at scale. And so we have the advantage that our system is very much like an electrolyzer, and so there's a proven set of vendors and equipment, and we're very similar to components that we have to use, so we can follow the same cost curves, but we still have to build it ourselves. We have to put those relationships together and actually scale our system. So that's probably our biggest hurdle from now till then.
Awesome. So for those of you who aren't familiar with venture capital, we invest in these companies, right? And our sort of worldview is like, what can this be when it grows up? And that's part of my prompt question. So from my lens, I go, okay, well, Natasha's going to bring the hydrogen economy into reality, and we're actually going to use hydrogen across our economies. Mina's going to have carbon net fibers in every material that we use around the world and produce it sustainably, and Curtis is going to power everything with carbon-free baseload power. So this is what is exciting from my perspective. And just to sort of shift gears a little bit, I want to talk a little bit about partnerships. And I think the most important aspect of growing and building a company is finding the right partners who get you and understand what you're doing. They see the value of what you're bringing into the world, and they're there to help you along the way to get from zero, i.e. lab scale, to real commercial industrial. So I wanted to talk a little bit about those partnerships, and I know obviously you probably can't share the names of all of them, because of confidentiality, but to the extent that you can share who've helped you in your journey along the way thus far, and how have you found these partnerships, and how have they culminated in sort of your incremental successes along the way so far?
I don't mind jumping in. So I'm very, selfish, I guess. I like to just ask for help. Like, I'm the first person to say, I don't know, I'm just going to ask for help. I've been that way my whole career, and I feel like you do better and you move faster and get there and build better if you're leveraging support and resources. And I've believed that my whole career, and so starting Ayrton was the same thing. It's been down to even small things like this building owner, Aspen Properties. They helped furnish our office space. All of our desks and chairs and such came from Aspen. Like, I'm down to like asking for free desks. I will do anything to help build our company. But other partnerships that we have some really strong, I would say, investors. Been very fortunate. We have the best investors that are very hands-on, very helpful in making connections for us, helping us figure out the things we don't know, everything down from the technical to the vendors to supply chain. So that's been extremely valuable. Corporate partners helping us build those relationships with the vendors that we need. So we're getting, low cost electrolyzer components from all different places in the world. One of our partners is in Taiwan, and they build balance of plants for fuel cells and electrolyzers. And so we're leveraging them already and leveraging the Asia ecosystem for low-cost components. And so that's been really helpful. So yeah, I'm just, if you meet me and talk to me for more than 2 minutes, I'll probably give you my card and say, if you can help me, here's my card. If you can introduce me, here's my card. I'm very selfish and greedy, I guess, that way. But I think that the way we build things at scale and to do things quickly and strong is to get help. So thank you in advance for everybody that's helping me.
I'll just jump in. So likewise, I may not be as forthcoming, but from our perspective, we look at it as projects. So how do we create projects everywhere that we can use our technology? And that's a big, big world, and there's many, many jurisdictions in that regard. So when we talk about partnerships, we look at building many, many different aspects. So obviously the supply chain. Supply chain is critical. Within geothermal, that supply chain is in general following on within the oil and gas industry, which is great. It's pre-existing. That allows us to obtain some very, very globally accepted specialists in order to actually do our tool design, do our directional drilling, do our turbo expander design. That's fantastic. Likewise, when we start looking into putting land projects together, which are the foundations of our projects, we're constantly in conversations with working with whomever to build those projects and secure those lands. And then we look to offtakes. So our first offtakes is with the Utah Association of Municipal Power Systems, which is the largest energy cooperative in the state of Utah. But we're constantly looking to partner with these different groups for different aspects. So in that regard, it's an offtake. But then when we quickly realize there's Evok has been fantastic as a partner on the equity investment side, but every project requires that project financing, which is required a lower cost of capital. So we are looking to partner with financial institutions that can come in with a lower cost of capital on that infrastructure / project financing. So that is, when we talk about wildly successful, it's all of those working together to build projects. So, from my perspective, if someone knows how to help me build a project, I'm your friend.
And for me, I had a mentor that was saying, for the partnership, if you want to structure that, use your chemical engineering background and knowledge. The deal won't flow if there is no driving force, like heat flows when there is one side cold, one side hot, right? So he was teaching me to find initially the driving force for the partners. Some have the philanthropy motivation. Some have really the bold mindset to be the first in the market. Some has financial return mindset. So finding that driving force and seeing early on if it's matching with your vision it was the first step. So I had two really great collaboration with two energy company here in Calgary, Ribbolite Energy and then Kiwetnock Energy. And both of them, similarly, we designed a licensing program, and that was very helpful to collaborate on even designing a business model early on. And they helped me not only to turn that into a business model that later can be used for finding more licensors, but also early traction for getting financing. That was what I had. And the other very important collaboration that we have with our end customer, that's we're working with one of the largest Fortune 500 beauty and fashion companies of the world that they have that mindset of being the first in the market to use carbon nanofiber for the whole packaging for beauty applications. And they were day to day with us in giving feedback, giving guidance, and walking us through the step ahead of us. And I think from that mindset of they wanted to be the first. That was their driving force. So how to design the deal for them to always secure that motivation for them. And then my mentor was saying that always look to close the mass balance, right, and heat balance. Whatever you're giving and whatever you're getting, balance that. So that was the mindset that helped us to have good partners.
Awesome. I want to talk a little bit about your teams and the people within the companies that you guys are running. Talk about the ups and downs of bringing on employees into a startup. And also, what's the culture of your company like? How do you set the tone?
I can go first. 2 years ago, one of the employees raised hand in our town hall meeting and said, what is our company's culture? And that time I said, freaked out and said, what is really our company culture? And I haven't thought about that 2 years ago. So I have just smoothly passed the question to give a fantastic CEO, positive conversation, inspirational. But after that, I started really working on what is our culture, work with our human resources or chief people officer. One of the challenge for us is that we are at the same time 3 companies. We are doing engineering work, we are an operation company, and we are technology development. So for each of these type of companies, you need different cultures. For operation team, you need consistency, just go and do what is told to you to do. For the technology, you want that fail fast, learn fast mentality. And for the engineering, you want the project mindset that don't spend more money, more time, just be on the scope of the project. So it was quite challenging to build the culture that encompass all of that. So the way that and we had done a lot of mistakes. We brought operation culture when we needed R&D culture, and we had to let those people go. Or opposite, you needed an operation culture, and you were hiring somebody that is R&D culture. So I think the biggest learning for us was that in each transition period that we have, we bring people that can switch from one culture to the other and be able, like my VP Tech Operation is a fantastic example. He has been a professor at university, so he understands technology development, but he was also director of technology development at Suncor. So he knew how to really switch when it's time for project development and engineering versus when the technology development. And those type of people have been very helpful for a smooth transition from one part of the company to the other part.
Sure. I guess what would be our culture? This is my 4th company, and I would say you have to be passionate if you are going to have a small startup. That's number 1. The other is you have to be committed and able to execute. So when we think about our style and how we do it, it is my job and the team's job to empower everyone. So that is critical number 1, and they're all very, very competent people, and that's why I'm confident that we will be successful, because again, all of us are working collaboratively to assist each other to make sure that that individual is successful in whatever they're doing, whether it's operationally or trying to put a project together from the land perspective, and that's why we're always looking for those great people. Always, continuously, and always wanting those people to come in, because that makes the company that much more effective, and yeah, so that's how we look at the people side. That said, we fall within an industry that is collaborative. So we have 6 employees permanently, but we probably have about 20 consultants at the moment, and that number is only going to grow higher and higher, because that is the industry and the supply chain that you're feeding into. That's how it works, and you do that on purpose, because most companies can't handle that big G&A. So again, we're collaborative across, just outside of our own company, with other firms in order to create that environment.
Yeah, so I think we talk about in our team that we're putting the hard in hardware, because we're building not just one reactor, but 2, one to store and one to unstore, and we're doing chemistry. So it's a lot of hard work. So our culture is a lot of conflict. And it sounds scary to say you have conflict on purpose, but one of our core values is that we're about getting it right, not being right. And in order to get things right as a team, you have to check your ego at the door, and you have to say the hard things. So truth is really important, and it's not just saying what's honest, it's saying the really hard truths. Like, this isn't working, what we're doing isn't going to work this way, you know, we need to make a change. And so I think for us, having that conflict is really key for us, because it's challenging each other. Because we're doing such hard things, we need diversity in thought, and that challenging and conflict brings that diversity for us. And when you have that level of conflict that's based on trust and respect, it gives everybody clarity on what you're doing and why. And that really helps us, you know, drive forward into being successful and to achieving everything that we're achieving. So we have a high performance team. I'm super proud of my team. I probably don't tell them enough, because I'm usually somewhere like this talking about how amazing the team is. But they're a high performance team, and they trust each other, and they challenge each other every day.
Awesome. Okay. The world is a complicated place. There's been a lot of change, not just in Canada and the US, but worldwide. If you could wave a magic wand and change one thing to accelerate innovation in Canada and worldwide, what would it be?
I'll start on that one. So within the geothermal space, we've gone within 8 months from what is geothermal to an extremely hyper-competitive situation where we have massive amounts of capital coming in across multiple different companies, and all with the goal to create mega projects. And that is what's happening right now in the United States. The conversation is we've moved from renewable energy to energy security, and we need megawatts, if not gigawatts, yesterday. Having done this in the past, I look at it and kind of go, well, it takes a few days to do that. I don't know how you're going to do that practically. However, that is what's happening right now. So the push is extreme from, you can call it the Mag 7, whoever you want to call it, or the Mag 9, it changes. But the desire for electrical generation is changing our world right now. So that's the backdrop. So within the geothermal space, inevitably, the only way to scale is, again, to get that lower cost of capital. I do have some competitors that have raised $1 billion now, and they're soon to raise an additional B in the next very short period of time. That, as an equity investment, is not how you scale a project. You need to get a lower cost of capital. So when we think about how we're achieving the goal of creating all this electrical generation, we need to have access to that lower cost of capital. So one of the aspects that you're starting to hear of within the United States, and I wish for it to occur in Canada, is a little bit more on the catalytic funding for smaller projects in order to get that base of that productivity to remove the risk component. Because right now, it's very difficult for the banks to underwrite anything when they can't see the product. And that is why solar was so powerful, because literally it was coming off of a factory. You knew exactly its degradation profile, very easily to financially wrap it, bang, and finance it against a power purchase agreement. We need to create that. And interestingly enough, within the oil and gas industry today, we take it for granted that, it's a great industry, yada, 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 but it's built on all those individuals that grew their companies within the 90s when oil and gas was considered our tech industry. And there was hundreds of companies running around trying to do something different, and they were financially able to do so. So we need to create the opportunity for small projects to move forward catalytically to eliminate that risk profile, and then that allows the banks to participate.
If I could, magically change something, I would change the a little bit less competitiveness. So more about the and than the or. It's very frustrating when somebody says, oh, what are you doing? And you're like, hydrogen. And they're like, oh, I hate hydrogen. I like batteries. I like batteries. Can't you like batteries and hydrogen? You know, like, it's okay. You can like both. Because, like, to build on what Curtis is saying, the world needs more energy. You know, we just need more and more and more. We've never needed the amount of energy growth that we're going to see in the next 10 years is unprecedented. We haven't seen that level of growth in ever. And so we need all the energy. We have to, you know, embrace wind, solar, geothermal, oil and gas, you know, hydrogen. We need it all. And so when we start competing against each other and saying, well, this dollar is only going to go to, you know, this type of technology and not that type of technology, you're holding back the end goal is solving for energy, and we need everything. So I want people to embrace the and, not the or.
Okay.
I'll be more quick. If I could magically change something, it wouldn't have been about economic. It would have been more about social culture that is happening, especially in our neighbor country. So I'm pretty concerned about the way that the world is communicating at this moment. Like, the conflict is something that can be helpful, as what Natasha was saying about her company. Like, the conflict between batteries and hydrogen, the conflict between economic values could be very helpful if there is rational in the communication. And there's some aspect in the culture that is becoming so normal, the way that the politics are communicating, that I'm very concerned that as we just talk about culture, what the leaders of the company do wrong, that goes within the whole organization. Now imagine when that comes with one country and then comes with other countries. So that, I think that's something that I'm pretty concerned about.
I'd just like to add a little bit to give a flavor as to kind of what's happening right now. Again, everyone here is here because we have a vested interest and want to create an energy transition and generate, in my case, renewable, no-emission energy. But the world has changed to the point where we all hear of data centers, but we may not fully appreciate their scale. So I know of one case, and you can look it up later, where the load that is being actually put together is the load currently of the city of Calgary. And they have rented a quarter of all the natural gas-fired generators in the United States to actually make it happen and work right now. So that just happened. So, you know, again, and from a renewable perspective, we're saying, well, hold on, I need to prove this out. I need to do, you know, all these tasks and all these things, and in order to ideally make the world a better place. But the world is changing, and that is actually what's happening. So the demand side is going like crazy, funded, very, very well funded, and they're leaning on just-in-time solutions, which are prior methods of electrical generation. So again, that's what the world is in the last 8 months, different.
Okay, final comment here. I'm going to ask and pull a card out of Natasha's book. How can the people in this room help you today, tomorrow, in the future? What is your shameless ask? Natasha, you can go first since you're the queen.
Okay. My shameless ask is, so our go-to-market strategy is to focus on where people are producing hydrogen today or have hydrogen projects in the next couple of years coming online. And so if you are one of those people that have a project now where you're making hydrogen, oil and gas makes hydrogen, like we in oil and gas are the largest hydrogen producers in the world. We already have, people talk about hydrogen markets dying. It's not dying. It's already a $200 billion a year market because we already make a lot of hydrogen. But these big oil and gas companies that make hydrogen will make a second plant 50 kilometers or 100 kilometers from their first plant because it's cheaper to make a new plant than it is to move hydrogen. So we want to help unlock where that hydrogen is. And we talk to people who have stranded hydrogen already. So in those plants, you always make more than you need to make sure you always have have what you need. And so there's extra hydrogen there, and there's other places that could use hydrogen. We're trying to connect those. So if you're in that space where you need some hydrogen, or you're in that space now, and you're in that, or soon, and you're in that space where have extra hydrogen or stranded hydrogen, we want to talk, because that's our go-to-market, is to focus on those opportunities first.
Love it. Mina.
My ask will be easier. Follow Carbonova on LinkedIn. We're going to have a few new job posting as we're building our commercial demonstration unit. If you have anybody in your network, we'll be happy that you pass the job posting to it. And also, if you do see any driving force as I speak about our business, if that's something that you're interested, happy to chat.
Awesome. Great.
Likewise, we're always looking for great people, and thank you for saying that, reminding everyone. Again, if you have passion for trying to make change and affect change, I would love to empower the individual. We are a developer within arguably the Western United States. That's how we see our, from a business perspective. Internationally, though, we are in the midst of putting together corporate structures and enabling them with everything that we have in terms of financially, from a operational, from an IP perspective, and then enabling an executive within that firm, within that jurisdiction, to essentially build projects in that local jurisdiction. So when we think of Canada, we're partnering right now with the First Nations right now to build projects. We want to bring in partners that are wanting to create this Canadian entity to go and build projects. We can't be ExxonMobil in day one, and it's not going to happen. But we have to scale quickly because the need is now.
Awesome. We've got a few minutes to open it up to folks in the audience if there's any questions. And I think we also have an audience online as well. So if there are any online questions, happy to take those as well. Thank you.
Thanks very much. Excellent panel. Really super, super proud of all of you. I think I've probably touched each of you in your time. So it's just pride and respect just oozes right now. So that's the first piece. Curtis, you talked about small projects and the enabling structures to fund and trial those out fast, and in certain cases fail them fast. So that's a really good introduction to the government, because that's what they're there for and that's what they do. So I'd like to understand what level of engagement and participation and support you've received from government, any level, and then B, how you would encourage government to be able to do the entrepreneurial thing and quote unquote fail fast. And I'm going to give you a little caveat on that, because all of us understand as Canadians what failing fast looks like in government, because if government makes one error for 35 cents, you'll recall that what ends up happening is that particular bureaucrat gets pulled up in front of like a parliamentary hearing, right? Because that's how we punish people in this country. So think about what you would do to encourage government to help Canada fail fast, given our need for productivity, but also what the underlying structures are to support that as well.
Awesome. I can start on that. So there's a few things to unpack in that. The first one is I appreciate the more conservative approach from the government. When I think of venture, I think, and hopefully Rototherm is the one. You hear these stories in venture where they invest in 20 companies and hopefully one works, and I'm like, hopefully I'm the one.
That's my hope too.
but there has to be a little bit of that in the government. So, you know, when I started in my career, everything was funded through private equity. Actually, originally it was started through flow-throughs. And you'd run around with a hat and everybody would have a flow through, and that gave the tax credit back to the investor, win or lose, hopefully, and then we progressed to the private equity, and then we progressed to the trusts and all these other things. But when we think about the private equity side, they've left that space for risk. Why? Because oil and gas has very low risk nowadays. But we need to transfer this. If we're talking about innovation, we need to go back to the risk, a little bit of that risk mandate. So inevitably, when looking to the government in terms of getting that feel of doing that early due diligence and getting that comfort, you know, you can do things obviously through the flow-through method in order to encourage investment, whereas not from the Canadian government or the provincial government, but also you can do matching fundings. You know, the EDC has a great program in underwriting POs essentially, or power purchase agreements, to allow you to then get a bank institution to come in. You know, those type of collaborative answers could work. But inevitably, you know, in my journey, until, and thank you, Erin, for stepping in, until Evok said, hey, I like this, everybody was like, most people were like, yeah, whatever, you know, like, or I couldn't even get past, you know, the one-liner. So inevitably, it always takes one to say, you know, I'm in for $1. Can you put in $1? And then all of a sudden it's like, well, hey, they put in $1. Suddenly there's, you know, let's look at this a little harder versus, you know, the sheer number of pitches. And arguably, if mandated for something like electrical generation or power generation or tied to a specific aspect, whether it be, you know, hydrogen or carbon sequestration, tying it to those as the motivation, then that is fulfilling kind of that risk, that mandate and the risk profile.
I'll add on to that, I think, and say that we've been very fortunate. We've gotten quite a bit of funding from different levels of government, about $4.5 to $5 million from Canadian governments and $1 million from the Singapore government. And so it's been great. But I would, one of my things that I think about is that they treat software companies and lifestyle companies the same as hardware companies and deep tech. And I think there needs to be a differentiation because it's great that you get the same, you know, little, here you can hire somebody, here use your little bit of money. And then it's like, okay, we need to move on and spread it around. That's great. But that can be very, very helpful to a software company, but it's a drop in the bucket to a hardware company. And so I think that we need to differentiate those when we're thinking about funding models from government, and more to what Curtis is saying, like if you're choosing your winners, choose the winners and continue to support them. Giving them the little bit out the door and then letting them fall isn't not helpful at all. And so I think it's just differentiating between the capital and more capital intensive businesses.
I want to add one point. I would have created a lot more investment tax credit. As different tiers, investment in different hardware, different earlier stages, depending on the risk that they are taking, they would take more benefit, and I would have focused, instead of reducing tax for corporate, I would have done more tax credit.
Final note there too.
Thank you, Heather.
I'm part of Canada's Clean Tech Alliance board, and we are kind of an advocacy group on behalf of clean tech companies in Canada, and sort of the ear to Ottawa in relation to how do we best support companies. I would say the biggest sort of front and center challenge for a lot of early stage companies is the loss of SDTC and the funding that enabled early stage hard tech companies, you know, to be able to sort of nudge their way into seed and Series A without having to raise nearly as much capital. It's a lot harder to raise capital as an early stage Canadian company, and so it was a huge catalyst for helping, I think, folks like Mina, you know, doing PhDs in academic institutions to sort of step out and have that sort of initial capital to support a company. So it's a huge, huge hole, and I think the impacts of that are catastrophic in relation to early stage clean tech in Canada. I'm advocating very hard to bring some version of that back into the Canadian ecosystem. There are other mechanisms as well that we're working for, but if you have any ideas, suggestions, thoughts, please send them my way. It's my job to help bring them forward to people who are listening. So thank you for bringing that up, Heather. I think we are pretty much at time here. Unless there's one last burning question, maybe we can take one more.
Good afternoon. Wonderful job, by the way. Quick question. There's the demand in producing hydrogen, electricity, et cetera. What are your storage solutions for what you're generating? Is there a method that we can move forward with other than batteries? Do you see any potential in I don't know.
I think that's right up her alley.
Yeah, so I'm not sure if you caught it at the beginning, but our company is doing hydrogen storage, and so we're creating a medium that stores hydrogen the same as a room temperature, room pressure liquid. So anywhere you can put diesel, we can put hydrogen. The same tanks, trucks, pipelines, rail cars. And I would argue that base load is great. The demand is always not base load, and so if there's extra energy coming from base load centers, we see a good fit for hydrogen to be generated, and then our energy to be generated and stored as hydrogen. So instead of storing for batteries are good for small volume, short duration. Long volume, seasonal storage of energy should be molecules.
Our system is essentially a heat pump, so we can turn it off and turn it on. It comes back on in 25 minutes. So we can do dispatchable. We can build up that energy base to actually far exceed our output for that short period of time, and then turn it off, do whatever you want. Whenever we said that, though, quite frankly, everybody was like, yeah, I don't really care, I only want baseload. So I'm like, okay, whatever. But arguably, in a more developed scenario, you would have a certain percentage of your products free-floating and to flatten out that grid profile.
Perfect. Thank you.
Well, thank you. Thank you to our amazing panelists, and appreciate you taking time out of your very, very busy lives to be here today. Thank you to all of you for being here as well. Big round of applause, please.
Thank you, Erin.